there can be a tree diagram where there are options given. So suppose there are two ways a person can go to school. One way is walking and the other way is going by bus. So this is option 1, option 2. Now after the person walks to school to a certain place, the person can either be on time or the person can be late. So late or not late. So this is by walking and this is by bus. If on the other hand, if the person goes by bus, the person can be late or the person can be not late. This structure, based on the structure of yes no yes no, is basically option 1, option 2, and after that option we again have option 1, another option 2, again another option 1, another option 2. However, what happens over here is that these options and these options are different. So it could be thought of the second part as option 1, option 2, and the second part as yes no yes no. This is similar to the structure of yes no structure. That means the first is yes, the second is no, then again yes, again no, again yes, again no. It can be thought of that structure, but a little bit modified version of that structure as options. So option 1, option 2, yes no yes no. The reason I'm saying yes no and here options, because the option can be increased. So in another situation what we can have is that we can have three options now. A person is going to school on a car, the person is going to school on a bus, or the person is going to school using a train. So now we have three options. So in that case we cannot think of this as yes no yes no yes no, but the second one will always be yes no. That means the second one, if the person goes by car, the person is either late or the person is not late. Again, if the person goes by bus, the person is either late or the person is not late. If the person goes by train, the person is either late or the person is not late. That means when we have this structure of option 1, option 2, that means we can actually expand it to option 1, option 2, option 3, and after that it is either yes no yes no. So that's how it works: option 1, option 2, option 3. So that is a common structure. Now since this particular math is something that we cannot figure out, what is the probability whether a person will walk or whether a person will take a bus, or what is the probability whether, it's not possible for us to figure out. So these types of probabilities will be given for us. So suppose the probability of walking to school is 50%, meaning 0.5, then the probability of going by bus is also going to be 50% by the not rule. So this is also going to be 50%. On the other hand, if the probability of being late, if someone walks to school, is 0.7 or 70%, and the probability of being late if the person goes by bus, and that is 0.8%, in that case we can figure out the other one by yes no rule, not rule. So if this is 0.7, so not late means 1 minus 0.7 or 0.3 or 30%. So if there's a 70% chance the person will be late after walking to school, there is a 30% chance a person will not be late after walking to school. So using the not rule. In this situation, if a person goes to school on a bus, the probability of being late is 80%, and the probability of not being late is 1 minus 80% or 20% or 0.2. So that's how this works. Here in this case, since there are two options, so these probabilities needs to be given. For example, if the probability of going to school by a car is 0.2, and here this is 0.3, and here is 0.5, that means we cannot use the not rule over here when there are three options, because there are three options. But since the total probability is 1, all these things should be add up to 1. So 0.2 plus 0.3 is 0.5, 0.5 plus 0.5 is 1. That rule has to follow. But since here there are two options only, we can use the not rule of yes no yes no. So suppose a person goes to school on a car, then the probability that the person will be on time is going to be, suppose, zero point 0.5, then late is also going to be 0.5. 1 minus 0.5 is 0.5. If the person goes to school on a bus, the probability of being late is suppose 0.6, then 1 minus 0.6 is going to be 0.4, using the not rule. If the person goes to school on a train and the probability of being on time is 0.1, then the probability of being late, not late, is going to be 0.9.